I wanted to just go back over a couple of little tricks with the calculator. A lot of people were asking questions about it. I thought if there's a video, you could watch it over again. Every calculator is a bit different, so if you don't have the same calculator, it won't be quite the same, but it'll be close enough. And this is a good trick. The first one is pretty simple, pretty straightforward. Probably a lot of people know about it, but if you don't, I think you'll find it really helpful. And it's just the way I would recommend doing things. So this one's pretty straightforward and pretty necessary. The second trick, which is the bigger one that a lot of people are asking about, isn't as important, but it's still very interesting. It's really important if you're taking calculus. So if you are, then it might help to start learning how to do it now. And it's just a function that the calculator has. A lot of people don't know about, don't know how to use, but it's really helpful. Okay, so if we're talking about this question here, okay, and what I'm going to do is I'm going to go shift sine, make sure I'm in radians of 1 divided by 3, and I get that answer, 0.3398. And the first thing that I'm going to do is I'm going to keep that answer on my calculator, and I'm going to do shift pi minus that answer. So this is one of the little tricks, is that answer button is really, really useful. It automatically has stored the last answer on your calculator. I'm sure a lot of people know about this, but if anybody doesn't, it's really useful. And that's going to give me this answer right here. Okay. And then I can take that answer and divide by 2. And I just click divided by 2. So again, keeping that answer on my calculator so that I'm not actually punching in any of these rounded answers into my calculator ever. I never do that. I always use the exact value on my calculator. And then I can take that one and add pi to get the last answer there. Okay. And then I'll probably, after that, I'm going to go shift sine 1 divided by 3 to get back to this step, and then divide by 2 to get this answer, and then add pi. And see, I don't have to punch anything in. I just keep using it, and that gives me this last one. And I've got all of them rounded to 4 decimal places, but I didn't round any of them until the very last step because I kept that answer on my calculator. That should be something everybody's definitely doing 100%, but if you aren't doing it that way and you're punching decimals into your calculator, try to get in the habit of not doing that, because it's a really helpful tool in any discipline. If you're ever using a calculator for anything, that's how you want to do it. Now the bigger one, this is the big one. So we got to go down to this one. And this was the trick that I was showing people for this. This is how you can check answers. Now, checking rounded answers isn't going to work as well. It's not going to be as reliable. You might be able to do it, but it would require a bit more work. But checking exact values is actually pretty easy, and it's pretty slick, pretty cool. So we're going to practice with this. The first thing that I have to find on my calculator is this button alpha, and this is red, so it goes with these red guys. Okay, so if I want the letter A, I hit alpha, then I hit this button to get the A. And the next one that I need to find is, I'm going to use shift, and shift is like yellow, so, or orange, whatever you want to call that. And the STO stands for store, so that's how I'm going to store values. So those are the couple of combinations that I need. I need alpha, A, because I'm going to use A, and shift store. And this is how you do it. Every calculator is a little bit different, but a lot of people have calculators like this Casio or very similar to it, and so it'll work the same way. So first thing I'm going to do is I am going to punch that into my calculator, and I do it as so: 6 sine, it's 2 theta, so 2, and wherever there's a theta, I go alpha A to bring up that A. That's the variable that I'm using, and that, like, instead of theta, because I don't know if they have a theta, but they've got an A. Okay, and then I got to square that, minus sine of 2a, and if your calculator doesn't open brackets automatically like mine does, then you'd need to include brackets, close bracket, minus 1. Now I've been doing this already, so when I hit equals, it might steal the show a little bit here, but usually you would probably get some gibberish decimal or maybe even an error. Like you might get something wonky when you type this in. Okay, so there you go. So I just got some random decimal, but that's meaningless. I'm not worried about that. Now here's what I do. I find my solutions and I go shift pi divided by 12. Okay, so that's my solution. And then I go shift store, and I don't have to hit alpha this time. I just hit A because it knows that I'm going to store it in a variable. So this is the decimal version of pi by 12. And then I scroll up to get back to that line where I typed in the whole function, and I hit equals, and bam, I get 0 because it was equal to 0. And then I can do the same thing for 5 pi by 12. So 5, and I can check my answers really quickly. Shift store A, scroll up, equals. And then my next two solutions were 13. So 13 pi divided by 12, shift store A, scroll up, equals, get 0. And then the last one I believe is 17. Yes, shift divided by 7, stored in A, scroll up, hit equals. So I just checked all 4 of my answers, and they certainly gave me 0, so I know that they're correct. And I can, and the nice thing is, if I want to check all 4, it's quicker doing it this way than typing the whole thing in every single time. And if you make one mistake and you don't get 0, it's tricky to go back and find it, and it would be a big pain. And as I said, in calculus, we do this a lot. So you kind of have to learn this functionality on your calculator in calculus. But it might be useful in this course as well. I could maybe check one of these values. What happens if I do that? 1.7407, shift store in A, scroll up, equals, and I get something very close to 0, but not 0. I don't know how reliable that is, so you are sort of taking your own risk if you want to do that. If I got 100 there, then I might think that I've done something wrong, but it's hard to say when you're punching angles in to sine and squaring them and multiplying them by 2 and stuff. Even rounded answers could maybe come out kind of strange. I would imagine usually you would get things close to 0, but I haven't tested enough to know that. You could do shift sine of 1 divided by 3 equals, and then I have to add pi, because this one was negative, so we had to go to quadrant 3, if you recall. So add pi, and then divide by 2, okay? And I should have that first answer exact now, not rounded. And if I go shift store A, now it's stored in A, and then scroll all the way up to find my guy and hit equals, and then I would get 0. But that's a little bit of extra work. I'm not sure if it's worth it unless you had a lot of extra time. Anyway, I hope it's helpful. There's a lot of things that the memory functionality of your calculator can do that's really useful. And if you've got a calculator like this, you've got A, B, C, D, E, F, M, X, Y. You got all these different variables that you could store different values in and do pretty complex things. Usually we only need one, but you never know. Hope you find that helpful.